Welcome to Secrets of Earth. I'm Patrick Viersba, and we are kicking off Season 3 by journeying to the continent of Asia, to a place where the line between land and sea is entirely erased. This is the Sundarbans, the largest tidal mangrove forest on Earth, stretching across the deltaic borderlands of India and Bangladesh, where the Ganges, Brahmaputra, and Meghna rivers converge and dissolve into the Bay of Bengal. It covers roughly 10,000 square kilometers of flooded islands, tidal channels, and tangled root systems. Twice a day, the tides sweep in from the Bay of Bengal and swallow portions of the forest entirely, flooding the mudflats, submerging the root networks, erasing whatever land existed hours before, and then retreat, leaving behind a landscape that has completely rearranged itself. Twice a day, the forest drowns and resurfaces. Most apex predators require stable, predictable terrain. They need ground they can trust, sightlines they can rely on, territory they can patrol and hold. The Sundarbans offers none of this. And yet, at the top of this impossible food chain, swimming between islands and threading through a maze of razor-sharp roots and brackish water, lives a tiger. The Bengal tigers of the Sundarbans, one of the last viable populations of this animal, numbering somewhere between 215 and 230 individuals across both India and Bangladesh, are not simply tigers that happen to live near water. They are tigers that have been reshaped by the Sundarbans over generations, smaller and stockier than their mainland relatives, with a deeper reddish-brown coat that disappears into the reddish-brown light of the mangrove interior, and a behavioral repertoire adapted to a habitat that defies every expectation of what tiger country should look like. Today, we follow them into the drowned kingdom to understand how a big cat survives in a landscape that disappears twice a day. Most cats dislike water. The domestic cat, the bobcat, the lynx, they avoid it with consistent and sometimes theatrical dedication. Even mainland tigers, while known to swim when necessary, treat water as an obstacle to be crossed rather than an environment to be inhabited. The Sundarbans tiger has no such option. The Sundarbans is an archipelago, not a forest. It is a system of islands separated by tidal channels and river tributaries, and movement between territories, between prey populations, between potential mates requires crossing water. These crossings are not rare events or emergency measures. They are routine. Sundarbans tigers have been documented swimming between islands against strong tidal currents with a casualness that observers have described as almost contemptuous of the effort involved. What makes this possible is not simply tolerance, but adaptation. The tigers have developed what researchers describe as an expert long-distance swimming capability, a functional relationship with the water that mainland tigers don't possess. They enter tidal channels without hesitation, riding with or across the current depending on the direction of travel, surfacing and submerging as needed in a landscape where the boundary between aquatic and terrestrial environments is entirely fluid. They also use the water as a primary hunting tool. In the stifling heat of the delta, where the air temperature and humidity combine to make overheating a constant risk, the tidal channels are both a cooling mechanism and a tactical advantage. A tiger submerged to its chin in a dark tidal channel, drifting with the current toward a spotted deer drinking on the muddy bank, is nearly invisible. Its eyes, ears and nostrils remain at the surface, enough to sense, to orient, to time the approach, while the body is concealed below. The current carries it forward without sound. When the distance closes, there is no warning the deer can receive in time to act on. The river is not the tiger's obstacle, it is the tiger's weapon. When the tide recedes and the mud emerges, a different challenge takes over. The floor of the Sundarbans mangrove forest is one of the most physically demanding surfaces any large predator navigates on Earth. The mangrove trees survive in oxygen-poor anaerobic mud by sending up thousands of vertical aerial roots called pneumatophores, rigid, woody spikes that protrude upward from the mud at various heights and densities, creating a surface that looks like a field of organic nails. Moving quickly through this terrain on four legs is somewhere between difficult and impossible. The Sundarbans tiger has adapted to this through a movement strategy that is the opposite of the sprint and pounce technique that characterizes big cat hunting on open ground. They move through the mangroves with deliberate slowness, each step placed with calculation, each paw lifted clear of the mud before being set down again. The thick, calloused pads of their feet provide some protection against the sharp root tips, but the primary adaptation is behavioral. The tiger has learned not to run where it cannot run, and to wait where patience yields a better result than speed. The deep, adhesive mud presents a secondary problem. Every step requires lifting the full weight of the foot vertically out of the suction of the clay before the next step can be taken. For an animal weighing 300 to 400 pounds, because Sundarbans tigers, it is worth noting, are smaller than their mainland relatives, the result of generation of selection in a prey-limited environment, this constant vertical extraction of limbs is metabolically expensive. The shoulder and hip musculature of Sundarbans tigers is notably developed relative to their overall body size, a direct consequence of this daily demand. The territory sizes reflect the cost of movement. Studies using GPS satellite and VHF radio collars on Sundarbans tigers found average home ranges of around 110 square kilometers for males. This is the same order of magnitude as mainland tigers in some habitats, but the density of tigers in the Sundarbans, the highest of any tiger population on Earth, means that the tigers are managing the energy cost of moving through difficult terrain by working smaller, more thoroughly known territories rather than ranging widely in search of prey. When you know every root system, every tidal channel, every mudflat in your 100 square kilometers intimately, you don't need to cover ground you don't understand. Mastery is more efficient than range. In the Sundarbans, the physical environment imposes a specific sensory challenge on everything that lives there. Visibility is consistently poor. The mangrove canopy closes overhead. The tidal fog that rolls off the Bay of Bengal at dawn and dusk reduces sightlines to a few meters. The tidal channel cuts the sightlines further. And, unlike the open grassland or the mixed forest, the Sundarbans offers almost no elevated viewpoints from which a predator can survey the surrounding landscape. The Sundarbans tiger navigates this visual poverty with a sensory architecture built around hearing and touch. A tiger's ears can rotate independently, driven by over 30 individual muscles, far more than the human ear, which is essentially fixed. This independent rotation allows the tiger to scan a three-dimensional acoustic field, isolating and triangulating the direction and distance of a sound with a precision that does not require head movement. A deer wading through mud 80 meters away, invisible through the fog, generates a specific acoustic signature. The rhythmic squelch of hoof placement, the splash cadence, the particular frequency of water dripping from a lifted leg. The tiger receives this and processes it without moving, then adjusts its approach accordingly. In an environment where sound bounces unpredictably off root structures, water surfaces, and the thick canopy overhead, filtering the useful signal from the acoustic noise of the tidal ecosystem is a complex cognitive task. Research on tiger hearing suggests they can detect frequencies up to around 65 kilohertz, well into the ultrasonic range, which allows them to hear the high-frequency calls of prey animals and the ultrasonic components of sound that carry directional information most clearly in cluttered acoustic environments. The whiskers add a tactile layer to this sensory picture. They are not simply sensory hairs in the general sense. They are thick, deeply embedded in a dense pad of nerve tissue and sensitive to minute changes in air pressure and airflow. As the tiger moves through the dense vegetation of fog or darkness, the whiskers detect the deflection of air currents around root structures and obstacles, providing real-time spatial information about the geometry of the environment immediately ahead. In conditions where neither vision nor hearing can resolve the next 3 steps, the whiskers are mapping the terrain. The adaptive strategy of the Sundarbans tiger extends upwards as well as into the water and across the mud. While the image of a tiger is firmly horizontal, the stalk, the sprint, the leap from behind cover, the Sundarbans tigers have been observed using the lower canopy in ways that mainland tigers rarely display. The sturdy, branching lower limbs of mangrove trees, which typically begin a few meters above the mud surface, provide elevated platforms that the tigers use for resting, for observation, and, according to field reports and camera trap footage, occasionally for ambush. A tiger, positioned 4 to 5 meters above the mud, settled in the fork of a mangrove branch, presents a completely different sensory profile to prey moving below. Its scent does not reach nose level. Its visual presence, from an animal's ground-level perspective, is entirely outside the zone of typical predator threat assessment. Prey animals moving beneath the canopy are scanning the root line and water surface for threats, not the branches overhead. When a macaque troop passes below or a spotted deer moves under the canopy to browse on fallen leaves, the tiger has the option of a downward strike, using gravity as a force multiplier, the full weight of its body amplifying the impact of the initial contact. This is not a running pounce that builds speed over distance. It is a falling strike that converts potential energy directly into kinetic energy at the moment of contact. The mud below, which would slow a struggling prey animal, reducing its ability to escape a horizontal attack at ground level, becomes an asset in this context. Anything knocked to the ground by a vertical strike is already in a substrate that works against recovery. The tiger lands in the same mud, but it chose the moment and the angle, and its footing is prepared. This behavioral flexibility, the ability to hunt from multiple planes, in water, on mud, or from above, is what makes the Sundarbans tiger genuinely unlike any other population of the same species. It has not simply learned to tolerate its habitat. It has learned to use all of its dimensions. Perhaps the most physiologically puzzling question about the Sundarbans tiger is how it manages its water supply. The Sundarbans is surrounded by and permeated with salt water. The Bay of Bengal drives tidal surges twice daily that push brackish and saline water through the channel system. The freshwater input from the Ganges and Brahmaputra systems dilutes this salt to varying degrees, depending on season and location. During the monsoon, freshwater dominates. During the dry season, salinity rises throughout the delta. For much of the year, in much of the forest, the available surface water is too salty for a mammal to drink safely as its primary water source. Drinking significant quantities of salt water accelerates dehydration rather than preventing it. The kidneys require more water to excrete the salt than the water itself provides. Any animal that relies on brackish water as its primary hydration source faces a slow physiological crisis. The Sundarbans tigers manage this through a combination of behavioral and dietary strategies. They actively seek out freshwater, the temporary pools that collect rainwater in natural depressions, the less saline upper reaches of a tidal channel during monsoon, the rare freshwater springs on some islands. During the monsoon season, freshwater is abundant, enough that the salinity problem largely resolves itself. During the dry season, the tiger's behavior shifts. They range more widely in search of freshwater sources. They spend more time near the mouths of the larger river channels where salinity is lower, and they extract a larger proportion of their moisture from their prey. This dietary moisture extraction is significant. Spotted deer, wild boar, fish, crabs, and the other prey animals of the Sundarbans are composed largely of water. The blood and tissue of a freshly killed animal provide substantial hydration that does not come with the osmotic cost of drinking salt water directly. A tiger that kills successfully and feeds thoroughly is also rehydrating itself. The kill is not just calories, it is water. The physiological tolerance for higher than normal salinity that Sundarbans tigers appear to display, drinking brackish water under conditions that would cause distress in mainland tigers, is real and documented, but the precise mechanism remains an active area of research. What is clear is that the Sundarbans tiger manages its water balance through a sophisticated behavioral calculus, not through a single anatomical solution. The Bengal tiger of the Sundarbans is not simply a tiger that lives near water. It is a tiger that has been shaped by water, by the twice-daily discipline of the tide, by the mud that tests every step, by the fog that erases the sightlines, by the salt that poisons the available water. Every adaptation we have traced today, the swimming, the deliberate movement through the root maze, the acoustic navigation, the vertical hunting angles, the water budget management, is the response of a lineage pushed to its physiological and behavioral limits by an environment that offers everything a predator needs and makes accessing it as difficult as possible. There are roughly 215 to 230 of these tigers alive in the Sundarbans. They are the highest density tiger population on Earth, sharing the most complex and demanding habitat any tiger occupies anywhere, surviving in a forest that drowns twice a day and rises again. They are the most precisely adapted large predators alive, doing something no other population of their species can do, in a landscape that has no equivalent anywhere on Earth. And they are doing it at the edge of survival, in a forest that is itself under pressure from rising sea levels, saltwater intrusion, and the 12 million people who live on the margins of the delta and who have always shared this kingdom with a ghost in the mangroves. We share this planet with millions of stories, most of them unfolding in the silence of the deep or the shadows of the canopy. Thank you for journeying with me into the world of the Bengal tiger of the Sundarbans. I'm Patrick Viersba. There are many secrets of Earth if you only know where to listen. I'll see you on the next horizon. Until then, follow our coordinates by subscribing to or following the show. It ensures you never miss a step into the unknown.